All right, this is 7.4, hypothesis testing for proportions. This is the shortest section in the chapter, just a couple slides. So we're doing the same thing. We're testing our H sub O and our H sub A, figuring out if we have enough evidence to support or if we're failing to reject. But now we're going to do it with proportions instead of Z's and instead of T's. To test a population proportion for P, we are going to do these different steps. So just a reminder, if P is your probability of success, then Q is 1 minus P. That's your probability of failure. And we usually write those as decimals. This is used for politicians who want to know the proportion of their voters who favor a certain bill. Also for quality assurance engineers to test the proportion of parts that are defective. So we'll see a lot of problems having to do with politicians and with quality assurance. So let's write out the whole Z test. So remember, we have if n times P is greater than or equal to 5 and n times Q is greater than or equal to 5, we can find the mean for P hat is going to be equal to our P value, and our standard error for P hat is going to be the square root of P times Q divided by N. So when we plug it into our Z equation, it's going to be P hat minus my mean over the standard error, which I wrote what those are equal to up top, but I could also rewrite it like this: P hat minus P over the square root of P times Q over N. So it looks super similar to the equations we've had before, except for instead of them both being means, we have P values instead. So we'll do 2 examples, and that's it for the day. So it says a research center claims that more than 25% of adults have used a cell phone to access the internet. So if I say H sub O, H sub A, I know I'm talking about P values or proportions. I know that H sub O is the only one that can have equal to. The researcher claims that more than 25%, this would be my claim, which means less than or equal to has to be the opposite. It says a random sample of 125, so my N is 125. Say that 32% have used it, so that means my P hat is 0.32. We're looking at a level of significance of 0.05. So first thing, we have to make sure that N times P and N times Q are both bigger than 5. So we'll do that. We'll say 125 times 0.25 that's definitely bigger than 5, and N times Q would be 125 times 0.75, definitely bigger than 5. So since both of those check out, I can go ahead and do my Z test. So I'm going to plug it into my Z score. My P hat was 0.32. The P that I'm given is 0.25. Divided by the square root of P, which was 0.25, times Q, 0.75, over N, which is 125. So the P and the Q are always what's given. The P hat and the Q hat are always what you are testing. So at this point, you'll go to your calculator and plug it in. 0.32 minus 0.25. Whoops, not negative. Okay, so I can look at this right here, see my arrows pointing to the right. I know it's going to be right-tailed. Now let's figure out what our z is that we're testing. Well, since this is my level of significance to figure out my rejection region, that I know that it's right-tailed, I would do 1 minus 0.05. And I'm going to look in the back of the book to figure out what has a z-score of 0.95. Again, I'm looking at the z-chart. I'm looking at the middle for 0.95. I find that's 1.65. So if this is 1.65, this is definitely over here in the rejection region. So I would reject H sub O. Since I throw out H sub O and my claim is the only thing that's left, I would say I am supporting the claim. All right, let's try one more. A research center claims that 30% of U.S. adults have not purchased a certain brand because they found the advertisements distasteful. So I'll start out by writing H sub O, H sub A. I see I have percentages here, so I know I'm dealing with p-values. H sub O is the only one that can have equal to. It claims that 30%, so that would be exactly 30%. This is my claim. Therefore, I know this is going to be two-tailed because I see my symbol in H sub A. Keep reading. It says, you decide to test this claim by asking a random sample of 250. 36% reply yes. So your p hat, 0.36. We're looking at a level of significance of 0.10. So before we can do anything, we have to make sure that n times p, which would be 250 times 0.3, is bigger than 5. Definitely is. N times q would be 250 times 0.7. Definitely bigger than 5. So we can do this formula. I'm going to plug it into my z equation. Z is p hat, what I'm testing, 0.36, minus what I'm given, all over the square root of p times q over n. And I will go to my calculator, start plugging everything in. Okay, now I have to figure out what I am comparing it to, what my rejection regions are. I already said I know that it's two-tailed, so I have to do 1/2 times my Jesus fish and look in the middle of the z-chart. So if I look in the middle of the z-chart for 0.05, I find it's negative 1.65. So this has to be positive 1.65. 2 is going to be over there. It is in the rejection region. So since it's in the rejection region, I would reject H sub O. H sub O was the claim, so I do not support the claim because I just rejected it. So again, these steps look super similar. We're just plugging in with different variables. We have P's and Q's instead of T's and Z's like we did before. So here is your assignment. We will start it tomorrow together on Zoom if you want to. If you would rather just start it on your own, that's fine too. But that is the end of 7.